Good morning, class. So, after our prelim exam, we'll proceed to the next topic regarding power plants. So, start with, so I have my presentation entitled Geothermal Energy, but discover all other power plants that produces energy as well. No? So, name as many forms of energy as you can see from this slide. So, of course, we can see transmission line or distribution line. We can have like a battery, can be a form of energy storage. We have this one. So, it can be a form of fuels, fossil fuels that is found beneath the surface of the soil. So we have here like a source of fuel as well, like in a form of a gas station. So we have here a tower where there's an indication of a blade. No? Can be like a windmill like this one. No? So we have energy sources being plugged. Of course, we have atom. No? So this is for nuclear energy. In this one, we can see water containment. So this is hydroelectric plant. No? So those are the different energy. So what are energy or what is energy transformation? No? So we're talking about that here. So the objectives when we try to discuss about sources of energy involves the following. So learn about the different sources of energy, understand how one form of energy is transformed into another form, describe the difference between renewable energy, non-renewable energy, and exhaustible energy. And next, so what is energy? So we basically know that it's the ability to do work. Uh, so that when energy is transformed into uh, with some kind of work in the process where it may convert it into power. So with that power, we use that energy for transportation, to heat and cool our homes, and as well as electronic device and many other things. So what are the transformation involved, no? Dealing with energy? So we have here energy transformation is the process of changing one form of energy into another. So as you can see from the figure, we have biomass energy. No? We have solar energy, geothermal, wind, and water. Water by means of hydro, hydraulic plant, hydroelectric plant. So these are all uh, types of renewable energy. You have wind, geothermal, water, solar, and biomass. Okay? So this is a sample of an energy transformation. So from the heat of the sun, uh, so it goes to the tree and there's heat. No? So biomass in the form of wood. No? So if you are able to see what a biomass power plant, it utilizes wood, no, as a means of fuel. Energy from the sun is absorbed by the trees and plants and stored as chemical energy, no, through a process called photosynthesis. Thereby, when wood trees are born, no, they produce heat and light energy. So what is that heat? No? This one, the heat. That the heating value that we get, no, from uh, the burning of wood and light energy, no, because it gives off light, because it creates fire, it produces light energy are released as those chemical bonds are broken, no? So biomass is therefore the total quantity or weight of organisms in a given area. Okay, so that's the transformation from sunlight absorbed by tree by the process called photosynthesis. Then it produces lights and heat. No? Okay, you have another energy transformation. No? Biomass in the form of dung. What is dung? No? Energy from the sun is stored by plants. No? Before it was absorbed by trees. No? But the same thing, plants and trees are doing the process by way of photosynthesis. No? The plants are either eaten by humans. No? So they are eaten by animals and dung is produced. No? Therefore, dung, as you can see, the waste matter, no, from the animal. No? Dung can be born to release heat and sunlight energy. So this is in the form of biomass also. So we can use this also as a fuel, no? The waste matter. So another form of energy transformation is the result is fossil fuels. No? How does fossil fuels evolve? So what are the example of fossil fuels like coal, the oil, no? The oil that is being extracted from below the surface of the ocean, below the surface of the ground, and even natural gas are coming from beneath the ground. So these are all fossil fuels. So how does fossil fuels form? Energy from the sun is stored by plants as chemical energy by photosynthesis. Plants are eaten by animals, dead plants and animals. So if they die, they'll be uprooted, no? So they gradually rat, no? You know what is rat? They are rotting animals. So over million of years, they are compressed to make fossil fuels. So that's how our fossil fuels form and evolve. Fossil fuels are born creating heat and light energy plus emission. So you can extract coal, oil, and natural gas. Thereby, they produce heat and light, uh, energy plus emission. So that is the output of, of the transition from plants to animals. Uh, That's form part of the fossil fuel. So we have also another energy transformation, the wind power. Huh? How does wind produce power? So energy from the sun hits the atmosphere, or the clouds, causing winds. So when there's the application of science, decreasing temperature and pressure by means of the atmospheric pressure and temperature, thereby causing winds. So later on, the wind turns the turbines on windmills. You have a turbine on top of the blade, of the turbine blade, which generate electricity. So that is the wind transformation of energy. So we go to another energy, which is the wave energy. Now, I think you have seen this kind of tidal wave, no, or ocean wave that also drives the turbine. No? So energy from the sun hits the atmosphere, causing winds and therefore waves. The waves drives turbine, which generate electricity. Causing winds. Okay, so after the wave energy, we have the solar power. No? So you know already that solar is directly transmitted, but how the solar is produced? So energy from the sun is collected and stored in what we call photovoltaic cells. We have the solar panels to be used as electricity. That is the modern means of producing energy. Alternately, flat plate solar thermal collectors can be used to store the sun's heat energy. So we have the flat plate solar collectors, which can be used directly or to heat water to make steam to drive a turbine to generate electricity. Again, it will produce steam, no? Because it will boil the water, just like the what we have in hotels. So these are the forms of energy. You have the biomass, the dung, again the dung was the waste matter, no, coming from the animals. So we know the fossil fuel, we have the wind, waves, solar. So what we don't have here is water, but waves is intended also for energy transformation by running a turbine. Of course, we don't have diesel fuel, but also coal can be using the fossil fuel. So what happens here? We have the primary source and the ultimate product. So for biomass, what is the source? Sun. Huh? So it is the sun. Not necessarily that it will be the tree, but because the sun gives off uh, carbon dioxide and oxygen, no, to be used by the plants or trees, then the product would be heat and light. No? So next, the dung, of course, the primary. So the secondary only for the plants and trees. No? I mean the animals. Of course, the animals producing the dung, but again, the ultimate product is heat and light. So for fossil fuels, also the same, except that it also produces or have a product of emission. Then for the wind, we have sun that produces electricity. Uh, it cannot produce, the wind cannot produce heat and light, but it can produce directly electricity. Because by turning turbine, uh, directly rotating the blade by the wind, so it creates electricity. Then also the waves create electricity, and solar can create heat. That's why it can boil and produce steam as well as electricity. Okay, these are the forms of energy. So mainly the sun is the primary source of energy. Whether you like it or not, apparently when you use solar, that is direct, but for other forms like the biomass is said to be indirect. No? It's not go directly to produce the heat and the energy in terms of light energy. However, there are other forms of energy that do not involve the sun. These are geothermal. Uh, of course, geothermal are composed of the fossil fuels also. But since they are not involving the sun, so they are the exception. We have the nuclear. So it's not about the sun. Hydroelectric, although the sun does power the water cycle that drive this form of energy. So it is the sun that drives power to the water cycle. Okay? So that's the way it produces by means of a sun. So the thermal energy process looks like this. Uh, Sample in volcanic areas. Uh, we have the ring of fire. No? In the Pacific Rim of um, region, we have this surrounded with volcanic, the rocks uh, hit the groundwater. Uh, so there is heat transformation also beneath the ground. So these rocks, because this is volcanic area, so this high in temperature, so it is heating the water in the ground. No? Can you imagine that? Trying to boil water on the ground. No? It rises to the surface as hot water and steam. So that is now the basic source of the thermal because it it's uh, heated water, so it becomes steam and goes up to the surface. So the surface, which is the plant for geothermal receiving that steam, no? And then we know already what transpire after, no? We know the schematic diagram. Okay. So in some places, deep wells can be drilled down. So like this, you can dig a hole. No? Cold water is pumped down. So when it is pumped down, because of the opposite pressure, the water runs through fractures in the rock and is heated up. So it returns back upward to form as a hot water and steam. So the hot water and steam are used to drive the turbines which generate electricity for the geothermal energy. Okay? So after geothermal, we go now to nuclear energy. So these are the main component of the system. So we know for a fact that we have a nuclear energy in Bataan. So these are the main component. No? So we have the cooling system that goes with the cooling tower. We have the generator. The generator is run by this this nuclear. No? This is now the what we call the containment structure. No? The main purpose is to isolate whatever will happen. So the structure will support, will a mean to support the very highly explosive uh, cause of these nuclear cells. So we have here the control rods. No? You have the reactor vessel. So we have the reactor. So these are the rods, no, that will form part of the various cells. So these cells will create a large amount of heat. No? So this one, there will be constant water, no? That is filled to produce steam. This steam, we have the steam generator. No? So the steam generator will go to the turbine. No? So the turbine will turn and then converts to the generator, no? Creating electrical energy. So some of the nuclear fuels, like we have uranium. No? These are the primary source. This is radioactive elements involved in nuclear chain reactions in the reactor core. So reactor core is this one, this red part here. No? So this overall thing is the con- uh, con- containment structure. No? So this is the generator, steam generator. So it's like a boiler also. It produce steam. No? So this is the line. So normally it runs over the turbine. No? So produce large amount of heat. This one. So the heating value is very high. No? That's why, of course, there's no emission because of the containment structure and this kind of uh, fuel. I not like those combustion fuels, generating combustion fuels. So the heat transform is used to boil water. That's why there's a constant pump, no, providing the circulating, no, on this cycle. So most likely it's just the same as the ordinary boiler Rankine cycle, but here uh, this is the source of it. Unlike in the boiler, you are having a combustion furnace. So this is just similar to a furnace, but there's no fire. It's just a heat, no? Very high heating value is produced because of these uh, cells, nuclear cells, and the kinetic energy in the expanding steam, rotating the turbine, which drive the generators to produce electricity. So, so during this pandemic, the administration is trying to prove whether or not the nuclear plant in Bataan would be still useful. No? They are trying to investigate if the reactor is still visible and steam generator are present. Although other parts are no longer there, so that's part now of the discussion whether how to replace and it would still be feasible to replace and how uh, to make such kind of protection, no? The a very good protection whenever there will be a calamity or unforeseen event, no? Just like what happened in Chernobyl or the Three Mile Island. No? They broke out. An explosion was brought to the malfunctioning reactor or some parts of the system malfunction. So you can read about what happened to the Mile Island and as well as the Chernobyl case. So there was overheating. So the main problem now is the integrity, no, of the cooling system whenever there's malfunction of the reactor. So after the nuclear, we go to hydroelectric energy. Yes, hydroelectric energy. And then for wind, wind drives okay. Turbine, which generate. You know already what is the source of energy is from the water. No? Hydropower, the production of power through the use of gravitational force of falling or flowing water. So before the development of hydroelectric plant, there should be a means to construct a good structure, what we call a hydroelectric dam. No? So the electric dam is in this side. No? It contains the big amount of water, so it's reservoir. No? So we have the intake. So normally you have to control the intake of water, so minimal. So we have the pin stack. The pin stack is the one that controls the amount of water to get in. So we have something like a gate here. So a water gate. So we call it pin stack. No? So at the downstream we have the turbine. No? Turbine is also a rotating blade. No? So when it rotates, so of course, what will happen? It will create uh, also the spinning of the generator. No? So of course, it's a motor, winding motor. It also produces what we call charge of voltage. No? Thereby producing electric current. So this is the powerhouse. Of course, generator produce the electric current uh, for a fall of electric source. So it's going to be transmitted to this long distance power line. But hydroelectric energy are just limited to power production, like 2 megawatt, 10 megawatt. And most hydroelectric power comes from the potential energy of the dam water. Okay? Dam driving a water turbine and generator. Okay? So maybe you will be involved in hydroelectric plant. Uh, can be part of the design team or you can be part of the operating and maintenance team. So that's the case about hydroelectric plant. Next. Now we go now to renewable energy. So what is renewable energy? It is an energy, there's a definition here, that is collected from renewable resources, no? Which are naturally replenished on a human time scale such as sunlight, wind, tides, waves, and geothermal heat. So waste to energy and anaerobic digestion are also done but not discussed in detail here. So waste to energy, like the waste from combustion, it can also be utilized into energy. So you're using waste as an energy source to generate electricity, uh, like the one that fuel. I mean fuel producing a combustion. No? The hot gases can be converted into energy, like the flue gas. No? Okay, these are the renewable energy that we can also see in our local setting. We have the windmill, we have the solar, uh, we have also the ground source heat pump. No? It's like a form of geothermal. No? So heat, the one that is utilized as means of heat is coming from the ground source. Normally, some of the HVAC utilize this form of heat. We have the waves. No? We have also the offshore plant that this one extract fuel, liquid fuel. No? Have you seen that movie that there was overpressure beneath the how many distance? What is the distance? No, from the ground to the beneath. No, the ocean. No? But normally offshore is apart from the shoreline. No? So it's not an offshore plant. It's not located in the mainland, but in the ocean itself. No? You have to dig uh, as far as below. No, that's why we are fighting over our what you call this economic zone. No, because we believe that there's a lot of renewable energy that we can generate, like malampaya, no? Source of natural gas that is produced now to run some of the big power plant in Batangas. So the extraction pipeline goes directly to that area there, no? And that's used to run the turbines to produce clean energy. So, of course, we could not say that we are having a scarce of energy because we are still not having a blackout, but uh, every now and then, yearly, we have to really monitor how much would be the increased requirement in terms of we have a government institution that will be looking out after our renewable, I mean energy produced, no, enough to sustain the requirement of the NCR or the northern part of Luzon. Of course, in Visayas we have a lot of I cannot say sufficient. We have from Negros, we are also running there more plants like solar, so that would augment the requirement. Aside from the fact that we have geothermal there in the eastern part of Visayas. And of course, there are independent power plant producers. No? They produce small power plants to distribute this to the industrial consumers, no? Like in the processing zone. No? So there's also what we call independent power plant, mainly intended to supply a particular uh, client. No? So they can build 1 megawatt, 2 megawatt. No? Of course, these are regulated under the EPERA law. So later on, when you are in the practice, you can read more about that law and how it is, how energy is being transmitted no, into the different consumers in the region, and how does the government control it through the Department of Energy. So the world endowed with plentiful bioenergy, wind, hydropower, ocean, and other renewable energy resources. Non-hydro renewables are responsible for 32% of in-state generation. So when you see non-hydro renewables are all those renewables that are not related to water, no? Water power or hydro electric sources, a higher percentage than any other state in the nation. So, of course, the world is home to the country's first tidal energy device, no? Tidal. So, we also produce, as discussed, no? We have the wave, tidal wave energy. So, we have also what we call the ocean and energy thermal conversion, the OTIC. No? So, it's that's also a kind of temperature gradient, no? Producing current, not the current of electricity, but the current of water coming from the ocean. It's not necessarily the ocean, but there's a certain distance from the shore. No? So, and I believe there's already a plant operating in the northern part of Luzon, operating ocean thermal energy conversion. No? We have also the first working offshore wind turbine. So normally wind turbine operate at hilly places or mountainside. So there's a lot of supply of good wind. So we have also, aside from other renewable, we have the solar energy. So this is the solar thermal energy system. This is used for heating water for homes, or greenhouses and other buildings. Heat fluids to high temperature in solar thermal power plants. The solar voltaic device PV. No? We have mono and what we call this mono photovoltaic. There are two or three kinds. We have for the solar cells that change sunlight directly into electricity. Poly and mono. So this is the solar energy. So we have biggest solar energy can be found in China. Right? This one with a tower. We don't know if that is from Dubai, somewhat like in the Middle East, or it can be in US. No? We have also Atlas in India. India was trying to develop a good independent energy supply. So that's the dream, and what he came through. But they need the program to be backed up with probably the IMF or the World Bank, or they're trying to apply, and that so far the lot of the regions utilize the solar energy. You can see these are the big formation, no, of solar power panels. Every solar panels you can have 500 watts. So can you imagine how many 500 watts? No? So for example, you produce 500 megawatt. So you need to form all these. No? It can be series or parallel. So the overall total production can grow. No? You can produce or design as much as 1,000 to 2,000 megawatt, no? For this kind of energy transformation. So the main benefits of solar, so the system do not produce air pollutants. No? Of course, you cannot also consume all the source from the sunlight. No? So the sunlight is a renewable energy. Now we don't know if that's consumed totally. That we will expect that the sun will no longer produce light. No? So if the sun will not produce light, so entirely all our 24 hours will be dark. No? And we will blame solar energy for that to consume all the heat. So it would not happen. No? Some systems on buildings have minimal impact on the environment. So these are the limitations of solar energy. The amount of sunlight that arrives at the Earth's surface is not constant. That's why we have the efficiency rating is still limited up to 26%. No? They started with 16%. Now, due to the development of technology, the increases it for time now. So the amount of sunlight varies depending on location, time of day. So if you go to Europe, so that's uh, next next to the above the equator line. So you expect the what is called the term solar production. No? The the hours, no? That you can generate is only 2.5 hours a day. And in our case, we are under the nearest to the equator line. We are on that Asian Pacific region, or that part, that region is considered to be climatic, where sunlight is always present during the day, but still limited up to only 4.5 up to 6 hours. No? So meaning that 6 hours is the production of due to solar energy. No? So the harvest that we can produce is only up to 6 or 7. Sometimes the designer only use 4.5 hours to produce sunlight, okay, from sunlight. So the amount of sunlight reaching a square foot of the Earth's surface is relatively small. That's why the efficient is very minimal also. So a large surface area is necessary to absorb or collect a useful amount of energy. Next to the solar, we have the wind energy. Of course, we have here the wind turbine. So this one is the blade. So you can see the wind turbine here. No? Uh, this one, we can have the wind turbine. So the wind turbine is connected to this blade here. Uh, so this one will be rotating. So the turbine will also rotate. So the other end is connected to a generator, no? That produce the electrical energy. So the energy in wind turns two or three popular blades. So these are one, two, three blades around a rotor. So this is a rotor here. No? So the rotor can be like acting like 90 degrees. The rotor is connected to the main shaft, no? Which spin a generator to create electricity. So this is now the basic GE wind turbine. So this is what we call here. This part is the generator. We have the controller. So have you seen in the YouTube probably that in order to climb up to this level, there's elevator here, no? So elevator will be used to go up here on this chamber. No? So this is the pitch system. This is the rotor. So the rotor will be the one to convert or transmit the power to this uh, from this rotating blade to this one, this drive here. So this is the tower, this is the blade. So basically there is not complicated, no, parts inside this one, inside the chamber, no, or that above this tower we call this uh, that houses the wind turbine. So where's the wind turbine? This one, okay. This one is overall is the turbine part here. So wind energy. Wind turbines are mounted on a tower to capture the most energy at 100 feet. That is 30 meters or more above ground. They can take advantage of faster and less turbulent wind. So wind turbines can be used to produce electricity for a single home or building. Uh, there's the other design, which more also about wind energy. Try to convert the components, but still the main purpose is to produce energy by means of wind transformation. No? So that's the subject of new discovery. That 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 is a new discovery, but try to uh, innovate. No? What is the existing uh, device for such wind energy uh, uh, set up, no, or system. So wind turbines can be used to produce electricity for a single home or building. It can be connected to an electricity grid, no? Just like what happened here. No? So this is the wind energy. So you can see a series of uh, towers here. No? So you can see that also in a lot of movies. No? Even the helicopter will pass through this wind turbine, windmill. So the advantage of wind energy, aside from the fact that capital expenditure is also high, no? The capitalization requirement will also needs more uh, support or funding. So this is a clean and renewable source of power, cost effective, rapid growth of industry, large potential. So these are the disadvantages. Wind reliability. When there is wind, no wind. So of course, just like solar, if something will happen that there's no sunny day, it will be rainy day. So that also the disadvantage with solar. We cannot produce. You will be relying on the energy storage by your batteries. No? So threat to wildlife, yes, because you have to remove forests, no, to some extent, and the habitat of animals, no, they will be diverted in some ways. So noise and visual pollution. So there's also a noise because of the running motors and of course the reaction of the wind to the mechanical, no, systems. So and visual pollution. So how can you see a visual is a pollution? So after the wind energy, we have the tidal energy. So we know already the form of tide, like water falling down. So that's form of tidal. So we have the tidal stream generator. So there is one island that discovered this kind of technology, and they put up along the shoreline, tidal stream generator. Makes use of the kinetic energy of moving water to power turbines. No? So because of that water, no, moving from time to time, because the wave uh, effect. In similar way to wind turbines that use wind to power turbines. The same way with wind, no? Similar to water wave. So we have also the tidal barrage, makes use of the potential energy in the difference in height between high and low tide. So an example of that is the dam, no? Hydroelectric dam is the tidal barrage. So tidal energy advantages: clean fuel source, domestic source. Disadvantages: tidal power can have effects on marine life. Of course, yeah. So, so that area will be no longer a good habitat for fishes and other aquatic resources. The turbine can accidentally kill swimming sea life with a threatened invade. Of course, there should be a boundary to that. Some fish may no longer utilize the area if threatened with a constant rotating or noise-making object. Installing a barrage may change the shoreline within the bay or estuary, affecting a large ecosystem that depends on tidal path. Yes, but that part of consideration when you venture in that kind of project, no, that really affects the totality of the shoreline, bay or estuary. So this is wave energy, ocean wave. No? So there are also part of other in other countries that wave continues to go to, no, to the shore that create tremendous energy potential. Wave power devices extract energy from the surface motion of ocean waves or from pressure fluctuation below the surface. So wave energy advantages, renewable, environmentally friendly, energy, all renewable energy are having that advantages, environmentally friendly, compared to fossil fuel that cause emissions of toxic gases, variety of designs to use, less energy dependence from foreign government. Disadvantages can affect the marine, distort private or commercial shipping, dependent on wavelength for this operation, and poor performance in rough weather and visual noise issue. So we have also the geothermal energy. We mentioned earlier that this is energy from the bottom of the uh, soil. So geo stands for earth and thermal equals heat. The thermal energy comes from the heat produced by the earth. So this is boiling water here, because of the volcanic rocks below. So there's a tendency to pressure up. So the thermal energy is a direct geothermal form of energy, can be accessed in areas where hot springs. There are hot springs. General geothermal reservoirs are near the surface of the earth. So we can use geothermal heat pumps. You know what? Each back, we have a kind of mechanical air conditioning system. We call it heat pumps. They utilize the heat. Now that's why they call it ground source heat pump. So the main source of heat is coming from the heat of the thermal. So when the pump supplies heating to the heat pump itself, the other end is also cooling. That's the opposite of the heating process by virtue of the heat pump. The question is, are there two compressors inside the heat pump? Not necessarily, because that's if you operate the cooling, it produces the cooling. At the same time, it produces also the heating. So that is the kind of operation that you can have for a heat pump. You have the electric compressor and a heat exchanger to absorb and transfer heat. So you do have thermal plants also harness the heat of the earth to hot water and steam. This plant's heat is used to generate electricity. Okay, these are the advantages. Renewable energy, cleaner than fossil fuel. Disadvantage, cost of drilling. Okay, you have to drill below. No? Researching proper areas. So you have to study, conduct investigative study, and there are a substantial amount of geothermal or steam, coming from that location. So biofuels, these are the fuels that are produced biologically. So the two most common biofuels are ethanol and biodiesel. The biodiesel are also good for fuel, vehicle fuel. So we have the ethanol as well. So ethanol is normally used as an alcohol, It's mostly used as a fuel additive to cut down a vehicle's carbon monoxide and other smog-causing emission. So it is added to fuel. The biodiesel is made by combining alcohol using methanol with vegetable oil, animal fat, or recycled cooking grease. So there are also discoveries that made use of that discovered biodiesel. They try to combine alcohol with oil That's why a lot of some, I mean not lot, but some of the traders will buy your vegetable or will use oils and, and other cooking greases, recycled ones, because they are made to be manufactured into biodiesel. It can be used as an additive to reduce vehicle emission, no? Typically 20%. So what will happen inside the engine if you added this biofuel? So they claim that reduce the emission. No? It will reduce the elements there like carbon dioxide, no? The sulfur content, sulfur dioxide, in its pure form as a renewable alternative fuel for diesel engine. So these are the advantage of biofuels. It's also renewable, easy to source, reduce greenhouse gases, reduce dependent on foreign energy. No? So foreign because we are used buying natural gas. No? And have you seen that in big depot like depot for Caltex, Shell, or they may buy natural gas and also the production of LPG. No? So disadvantages, higher cost of production, lower supply than gasoline. It's very low. The law of supply and demand uh, applies scarcely to this kind of fuel, the biofuel. Monoculture, shortage of food, water use. So this is the renewable energy. You can see this from National Geographic. I think this is a video here, but I will not try to click that one. It's not clickable. So next, we have lecture 7. What is it? Hydroelectric power plants. No? We know already for a fact that it utilizes potential energy of water. So what is potential? No? Just potential when you transform it into kinetic or move. No? There's a movement. No? So there's the force going down to the impeller of your turbine, no? To generate electricity. These plants are generally located in hilly areas where dams can easily be built. So we have a lot of hydroelectric here in Cebu, the Matutinaw, that name, Matutinaw Dam, hydroelectric dam, somewhere in the southern part of Cebu. So the dam water is lead to a water turbine. Water's energy is used to move the prime mover. So what is the prime mover? A turbine or the generator, which in this case is okay. So we have the figure below shows a cross section of a hydroelectric plant. Now we have the parts here. So number one is the reservoir. So this is the lake. So we have number two turbine passages. This one mentioned last time is the pin stack. We have the turbines are like big propellers. This one. So we have the Francis turbine. We have the mixed propeller turbine. So what are other name? We have that last time I gave you a table. Pelton turbine. So this is the dam. It's a structure that supports this piping, no? And this whole big volume, also creating pressure and stress here in the dam. Because we have the river, no? So by mass flow balance, so there's always an outlet, no, of your volume of water. So this one pipe is your exhaust water. This one. This is the generator. Okay. I think we have already discussed it all. No? So we have The advantages we mentioned earlier about hydro. So the main advantage is cost-effective, environment, has longer life. They do not require long starting time like a steam power station. They can also help in irrigation and controlling floods. No? Disadvantage, high capital cost, transmission cost. So those are the disadvantage. So we have pump storage, hydropower plants. So instead of the flowing gravitational, we need pressurized power generated from water falling a higher lake to a lower. The operation is reversed during off-peak conditions by pumping the water from the lower lake back to the upper lake. So when you run out of water, so you have to bring back, reverse the water to your dam. No? During off-peak, when you see off-peak no? Condition by pumping the water. The power companies make a lot of money by selling the generated power during peak hours at high rate. This is now the good example of showing what a pump storage hydro. So we have here the reverse pump. No? So after that, off peak, okay, but also the tendency it loses no the level here. So you need to pump. This is the pump. You can bring it up again here. No? Of course, there's no problem with your turbine. It can just pass through here. No? So the pin stock will be fully open. Okay. The term is to reverse. No? So this is the pump turbine. So we have got the transformer here. So this is the powerhouse. No? So that's good thing, no? Instead of installing it here, so you install it here and try to pump suck it up through there. No, instead, aside from producing power here, you can also uh, produce water here, no? So intended for other purpose like irrigation or other use of water. So these are the general formulas: density, mass over volume, density of water, hydraulic efficiency times electrical efficiency is equal to overall efficiency. So available hydropower, what available water power in kilowatt, water flow on the head of water. No? So power equals 9.8 times Q times height. No? So this one, this formula. That one here. So example, a large hydropower station has a head of 324 meters. So you can see how high, no? An average flow of 1,370 cubic meter per second. So that's a very big no? Flow. The reservoir covers 6,400 kilometer no? Square kilometer. Calculate the available hydraulic power. The number of this power could sustain if the level of the impounded water were allowed to drop by 1 meter. No? Okay. So this is the solution. What is power is 9.8 times Q times 8. So that's 4,350 megawatt. Can you imagine that? You can produce with just a head of 324 and the flow of water is 1 to 70. So if you can if you can only have that from your area, you can produce already a big amount of power. No? So we have to find the number of days. No? So by using this formula, volume equals area times height. So equals 6,400 times 10 to the 6 cubic meter. So number of these using the 1 meter drop, that is the volume of water. So the rate of flow is 1,370. So we're looking at the unit rate of flow. We can reduce the time in seconds. So there are how many seconds? 6,500 times divided by 1,370 equals 4.67 times 10 seconds equals 1,298 hours. So 54 days, no? 54 days. That the question is uh, the number of days this power could be sustained, no? Before that allowed to drop 1 meter, because but the 1 meter is already uh, subscribed here, so that's the number of days when you reach a drop of 1 meter. Okay, I will just send to you the copy aside from giving you the discussion, no? Because this will also apply to other use. Example of hydroelectric power plant is a hydroelectric generating station supplied from a reservoir of capacity 5 times to the 10 6 cubic meters. So that's the volume of water. At a head of 200 meters, find the total energy available in kilowatt hour. So if we see total energy that in terms of kilowatt hour, for water, total volume of water is cubic meter per hour. If the overall efficiency is 75, so every power plant has efficiency output over input. So this is a solution volume equals 5 10 to the 6 cubic meter. The head is 200 meter. Q can be calculated already, huh? As 5 10 to the 6 cubic meter per second is given. So P equals 9.8 times Q. So power therefore is this one, no? What is that? 980,000 times 0.75 efficiency. So A, what that A for efficiency, no? Equals PT. So P is 98 times 10 to the 8 times 10 to the cube watt. Now that is watt times 1 second times uh, efficiency of 75%. We need to find out the energy in kilowatt hour. No? So we divide the above value by 3,600 seconds per hour times 1,000 kilowatt, no? Per 1,000 watt per kilowatt, and get the answer, which is 2.0416 times 10 to the 6 kilowatt hour. So that's the answer. The total energy produced. So homework, find the advantage and disadvantage of pump storage. You will answer this to me on our next meeting. Give me the advantage and disadvantages. Due to 1 week from now or our next meeting, no late assignment will be accepted. Submit hard copies only. Put that in your drive. No? So if you can recall the pump storage, instead of installing the hydropower house above level, we put it near the shoreline. No? So that's a reverse turbine there. No? So that's a reverse. Instead of the turbine going down, the turbine going up. No? So that's pump storage, hydropower pump. So that's the essence of pump use there. So normally, if some good manufacturer like Runpos uh, or other supplier, T&T, another manufacturer. We have a lot of manufacturer for pumps, so they can produce the turbine. So presentation. So we will not deal on this. We have the combustion turbine generation plants. So what are these? Combustion turbine. Remember our turbine for uh, the air, no, the air cycle for the aircraft, jet aircraft utilizes compression. There's a turbine there, no? So turbine or compressor. So the combustion turbine, power plants burn fuel in a jet engine, no? So that's the combustion turbine. That's why we have the high octane fuel. Use the exhaust gases to spin a turbine generator. No? The air is compressed to a very high pressure. That's where the compressor fuel is then injected into the compressor and ignited. So it can also be form of internal combustion engine, no? Producing high pressure and high temperature gas. The gas is used to move the turbine blade. The remaining gas is set out through the exhaust. No? So this is the one that powers up the jet engine. So what happens to the turbine generator? It generates electricity. But for the air cycle, it generates an air conditioning. No? For the inside the aircraft. So this is the section of the turbine generator. You can also imagine a big turbine for big plants. No? So you can have this one, a typical jet. So you can see here the intake. No? So part here is the compressor. So you remember our ice, polytropic compression will come in. Without it, key raised to the power of 1.4. No? So that's polytropic. I mean, yes. And second, you have the combustion part, no? Which is isotropic compression. And thereby producing combustion here. No? There is combustion that releases the exhaust. The exhaust said to be the one causing the turbine to this one. No? This turbine here goes to rotate, thereby producing this power. No? You know the power, the one that rotates the aircraft. So the jet uh, will have it uh, have this what you call this propeller, no? Propeller for both sides if you rotate that one, no? So advantages of combustion turbine power plant. One of the advantages is that they can actually be designed to be remotely controlled for unmanned sites. No? For unmanned. Okay? So they offer fast start-up times and fast installation. Imagine you have a small 1 megawatt, no? Turbine, combustion turbine. They can easily be installed. No? You just connect the supply of air and then the outlet to the exhaust gas line, and then you can produce already the power. No? The high octane gas will be used to fuel up. Excuse me for a while. Okay. In most cases, the combustion turbine generator package is a completely self-contained unit. So it's a package already. No? As you can see from the cross-section. In fact, some of the smaller capacity system are actually built on trailers. No? Imagine that combustion turbine as uh, big as the trailers. No? When you imagine the big trailers containing this in terms of transporting this to one side to the other during construction so that they can be moved quickly to sites requiring emergency generation. Combustion turbines can be extremely responsive to power system changes. They can go from no load to the full load and vice versa in a matter of seconds or in a matter of minutes. So these are the disadvantages. Limited fuel options, diesel fuel, jet fuel, or natural gas, and inefficient use of exhaust heat. So, limited. These are limited fuel options, i.e., jet fuel or natural gas. There are several environmental issues related to the use of combustion turbine. Without appropriate treatment, the emissions of undesirable gases can be very high. So the high temperature in the combustion chambers will increase the production, and sound levels can be high because combustion turbines are typically jet engines. They have low efficiency. So after the combustion turbine, we have also combined cycle power plants. No? So what are being combined here? The combustion and the steam. No? So what happens here? The exhaust gases after moving the turbine uh, can be passed through the heat exchanger. No? So after the passing the turbine, this heat, these exhaust gases will go to the heat exchanger, no? Where they can be used to convert water into steam. So instead of throwing away the heat gas, the exhaust, no, the flow gas, it's used to pass a heat exchanger. That heat exchanger will be the exchange, no, the heat transfer between water and the flow gas. No? So if you heat the water, it will drastically turn into steam. No? That steam can be used to move secondary turbines. No? Because of the high temperature, no, brought about by these exhaust gases, and just so wasted. No? In fact, there's a very low efficiency. So this low efficiency is now converted to higher efficiency because of the use to come up with a steam. The exhaust gases after passing through a heat exchanger can also be used for other heating process in central heating system. So you have a that's like for buildings, you can utilize the heat into your water heating system for use for hot water. No? So this is the combined cycle plant. So first, we have the compressor to suck the air. This compressor will rotate. Huh? So if this rotate, this also rotate the gas turbine. The gas turbine will produce electricity here. No? And after that, this fuel will go here. This exhaust gas line. So bypass here to the exchanger. This is exchanger between flow gas and water. No? So water is being pumped. So when water passes a element, heating element, it goes to the stream to another turbine which is heated. No? Just like the steam power plant. So that's utilize the combined cycle power plant. It produces now a higher efficiency. So this steam produced is also going to run a steam turbine. This one is another turbine, no? Gas turbine. This one is a steam turbine. There's 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 also a steam generator here. So we have a condenser. No? What is the purpose of condenser? Because the gas is in the form of steam. No? It's not dry. No? So it will be condensed. the gas will be condensed, brought back into in the form of liquid, no? And goes to the cooling tower. Cooling tower for cooling and then goes back again, no? Where does it goes back again after passing the cooling tower? No? So probably it goes back here to the pump, no? This one. So this will repeat the cycle. Yeah. So we have another homework, but you don't need to assign them right now. Only the pump storage. So we go now to wind turbine generators. We're almost done. So wind energy is converted into electrical huh, by means of windmills. Power produced is proportional to cube of wind speed. If wind speed is doubled, then the power produced is tripled. Advantages, we mentioned also just last time, no fuel cost. How can you provide fuel when the source of transformation is wind? No? Don't cause air pollution. Wind power is an example of renewable energy. So these are the disadvantages. You just read through these. The windmills need to be installed at site where there is unrestricted flow of wind at high elevations. So, constant dependence of wind. So we go now to solar direct generation. We use photovoltaic, no? Solar power panels. Use different materials which convert solar into DC. Now we need an inverter. No? DC to invert to AC. The panels can be connected in series or parallel to obtain the required current voltages. During off-sun peak period, battery can be used with this system. So you have three types of solar: off-grid, on-grid, and the combination of off-grid and on-grid, which is hybrid solar power system. So we have the solar direct generation, DC energy converted to AC by means of an inverter. So the advantages, renewable environment can be used for small power in remote areas. So disadvantages, very costly. Cost of conversion equipment is very high. So this is on top of your theoretical discussion. I believe you have already have some backgrounds, some formulas. But for those who don't have, we'll have to discuss that again. So thank you uh, for listening, and um, I will upload this to my to the YouTube so that you can just refer to that during your study. Thank you very much and good day. So you can read about what happened to the three island as well as the Chernobyl case. There was overheating. So the main problem now is creativity. You have this what you call this that they cannot okay,